Okay, let's start. In this experiment, we will try actually using ChatGPT as a virtual terminal. So we can imagine that this ChatGPT will act as a virtual Linux machine. And within this machine, we're gonna launch a new terminal. In this terminal, we assume that we have AWS CLI installed, and we're gonna use this to write some commands in the terminal to generate Lambda function, which do a sentiment classification for movie reviews. And we're gonna use AWS AI services in AWS to do this sample sentiment classification. And eventually we will test this, we will deploy virtually this Lambda function, and we will try to invoke the Lambda function to get a response. We will try to back up everything that we have done within this experiment and generate CloudFormation scripts to replicate the Lambda function and all of the related artifacts to be deployed to AWS. So let's start. I have the prompts ready here just to save time. So if you go right away to the prompts, we will start with the first prompt, which is, asking ChatGPT to act as a Linux terminal. And we will start by instructing ChatGPT to use any text that we're gonna write here as a command and showing the output of this command here. But whenever we need to write normal English instructions, we will put an agreement here with ChatGPT to just put this English phrases or English sentences in curly brackets. Okay. I have a bunch of commands here. The first one is to show the content of the present working directory. The second one to show the path of the executable for AWS. And the third one to show the version of AWS CLI installed in this machine. So let's see. Here we go. So first command executed, we can see the content of the present working directory. And second command, we can see that AWS executable is installed here in the user bin. And finally, the version of AWS CLI, which supposedly is 2.4.5 with Python 3.8. Okay, great. And let's move on. Let's make use of this AWS CLI to create two S3 buckets. One bucket to put the data set or sample test data that we want to do sentiment classification for, and the second one to save the output of the sentiment classification that we will be doing it through the Lambda function in AWS. Okay, now the two buckets have been created. Let's create a directory, subdirectory within our current directory. Make directory, and let's call it test dataset, for example. Okay. Let's see if that directory has been created or not. And here we go. You can see that test-dataset is already created here. And finally, I'm going to use echo command to take those reviews and save them in a JSON file. So just let me update the command in a proper way. So this is our data, which is a JSON format for the reviews, bunch of reviews. And let me just close double quotations here and then paste the remaining part of the command. What's gonna happen here, that this data will be saved in the subdirectory that we just created, which we called it test data set, and inside a JSON file, let's call it movie-reviews.json, and let's execute this command. Okay, great. Okay, I assume now if I try to just check the content of this test-dataset directory, I should be able to see this file created inside. Yes, it's already created there, movie-reviews.json. And even if I try to show the content of this file here in the terminal, I'll be able to do that in the same way with after writing this command. So movie reviews.json. Yes, here we go. These are reviews that we will use for the sentiment. Okay, great. So what is the next step now? The next step is to generate virtually, we will move the JSON file and store it, copy the file and store it in the S3 bucket. So let's do that. There's a command called AWS S3 CP copy from that source to a destination, and our destination in that case will be the S3 bucket for sure. So let me take this command and just update it a little to match the same directory that we just created. And from that directory, any content we have, it will be copied to the S3 bucket. Our S3 bucket called ml-dataset-1279. Okay. And let's see. Yes, indeed. As you can see in the output of the command, the file has been uploaded to this S3 bucket. And even if we try to check the content of the bucket, we should be able to see the file there using this command. Okay, let's see. Okay, great. The file is here, as you can see in the output of the command. Okay, let's move on. So the next step now is to instruct ChatGPT, our virtual Linux terminal, to generate Lambda function. And if you remember, we said in the first prompt that any English instructions will be inside curly braces or curly brackets. So as you can see, we just typed here generate a lambda function in Python to read the reviews file in S3 bucket, which has this URL or this destination. Use the sentiment ML service in AWS to classify reviews in this file. And finally, return classification result for each review in a JSON format, and save the generated code in a file called main.py on the current working directory. So let's see. If I copy this prompt and I put it here, but wait a second. Actually, the actual S3 bucket, it's not training the dataset. So let me just stop the generation of ChatGPT response and edit the name of the S3 bucket to match the correct one that we already created, and also update the file name to be the movie-reviews.json. And now we can save and submit again. As you can see, that actually prompt start to be executed to generate the Lambda function using Python. And as you can see, the generated code here in Python it's very logical. If you look here to the generated code, it's very logical. If we quickly can go through it, just importing the necessary libraries, and inside the lambda underscore handler function, we can see that Buto3 is used to create the client of the S3 and start reading from the S3 bucket and loading the content of the reviews file and creating an instance or a client of the Comprehend AI service in AWS, which is doing the sentiment analysis or sentiment classification for us. And eventually, we have the results array created, an empty array created, and within the for loop, we go through each review text, and using Comprehend, we use a method in Comprehend called detect sentiment, which takes the text of the review and return the sentiment along with the review itself. So in the result, we have a JSON object created, or a dictionary actually. That dictionary in the result, it's all about review and sentiment. And we take this result and append it to the results array. Once we are done here, we just return the status code 200 successful, and the body is just dumping this array to be returned as a JSON. So that's all here for the Lambda function code. And if you remember here in this prompt, we already requested ChatGPT to virtually take this Python code and save it in a file called main.py in the same present working directory. So if we go and try to check, do we really have this file created in the working directory? And yes, it is. It's created here, main.py, okay? What is the next step now? The next step is to zip the function, the file, which is the Python file of the Lambda function, as a zip file. Let's call it function.zip as a standard for Lambda function here. And once it's zipped, that zipped file is supposed to be also saved or virtually persisted in the same working directory. Let's see. Okay. And if again we try to check, do we have a function.zip file created? Yes, it is. As you can see, here we go. We can see the zip file created as well. And now our Lambda function is ready, and we can create we can actually create a rule. We need an IAM rule to be created with the required permissions to deploy this Lambda function to AWS. We're still actually doing a kind of virtual deployment, virtual creation, and we go from one level to another to simulate the whole process. Now, this prompt supposed to be used for generating a JSON configuration file for IAM rule policy, which has permissions to create and invoke Lambda functions, save the generated file on the current working directory as well in a file called role.json. Okay, so let's do that here. And this is a policy document for the IAM rule, which is required to create, invoke, and get the function. Okay, so we will use this IAM rule to create the Lambda function itself from the AWS CLI. So let's see how we're gonna do this. There's a command here to create the rule first, IAM rule, using the policy document, the policy JSON document that we just created here. So let's see that, let's do that actually. IAM create -rule, and the rule name is Lambda rule. And assume policy document is the JSON document that we just created above. Okay, so let's execute that. Okay, we have a note here from ChatGPT to replace the X's with actual AWS account ID. However, Amazon resource name for the created IAM rule. So with that, our command is ready, and we can just, run the command. This is a command. Great. Now the command got created. The function got created using the command, and the runtime is Python 3.8 as we specified in the command. What exactly we have here? We have here the command and the output of the command. The output is this JSON object, which listing all of the information about the created Lambda function. Now, what is the next step? I need to make sure that my Lambda function is operational and I can invoke it. So how to do that? I have another command here from the CLI commands for AWS, which I can use to invoke the Lambda function. Our Lambda function is review sentiment classifier. So let's update the name to be the right one. And what could be expected when we invoke this Lambda function? As we said, this Lambda function, when we check the code together, the generated Python code, it's all about reading the reviews from the JSON file, which we have in the S3 bucket. And after that, it's doing the sentiment classification using the AWS AI service. Comprehend. And after that, the response will be returned in this file, response.json. We're gonna save the response for the sentiment the detected sentiment in a file called responses.json. So let's take this command to invoke the Lambda function and try to run the command from the terminal here. Very cool. Now, as you can see, when we try to invoke the Lambda function, we got status code 200 successful response from the service from the Lambda function. And we expect now, if we checked the response to JSON, that response to JSON should be there, and we can use the cat command to see the response to JSON content. Here we go. You remember we have the review text and the sentiment now. So the sentiment is shown here. And that sentiment is already returned from the comprehend AI service. And the response looks to me reasonable, logical, because it's showing some positive, negative, and neutral sentiment for the reviews. After that, we can check the information about this Lambda function as well, listing the Lambda functions with this command. So it looks like a real Lambda function in a real AWS environment. And if you can see here, this is our Lambda function, the function name, and this is the ARN of this function, and this is the runtime, and the rule that we created, and many other attributes and properties about this function. Very cool. I think it's very realistic experience in terms of simulating creating the Lambda function, and this is exactly what we usually do when we create Lambda functions using the CLI commands. And the last thing here related to this part, we can use something called get function URL -config and just pass here the function name, which is this one. And using this command, we should be able to get even more information about the function URL as a response or as an output for this command. So let's see. Yes, great. You can see we get we can get here the URL, and in this URL we can see the whole URL for the function, which we can utilize to make a curl command, for example, if you want. Okay, great. So our last step for this demo is to use this prompt to generate cloud formation template. That cloud formation template will be used to create the stack, and that stack will contain the Lambda function and the same Python code that we generated in the main.py file, in addition to the IAM rule, which we have in the policy document, role.json, and finally save this cloud formation template in the current working directory in a file called sentiment lambda stack.yaml. So it's a YAML file. And if we go here, now ChatGPT will start generating the crowd formation, and as you can see, ChatGPT is able to track the whole context of the conversation. So based on all the previous responses that we already generated from ChatGPT, we'll be able to aggregate all of this in the final crowd formation template. This is our YAML file. Keeps going. So if we try to see if the file has been saved or not here, yes, indeed. We have the file created here, the YAML file created for the crowd formation template. And if we use this crowd formation template to deploy our Lambda function, we'll be able, to do that easily from the AWS console. And with that, actually, we came to the end of this experiment or this demonstration for using ChatGPT to generate a Lambda function, which doing a sentiment classification and saving the output in a response file. And even we generated the crowd formation template as well, which will help us easily to take bundle all of the things that we generated from ChatGPT and deploy it to the AWS console. Thank you so much and see you later.